Good evening, all. Yeah,
Good evening, sir.
thank you for joining today's professional development session 11. Today's topic is energy conservations from critical environmental area. So, how many people believe what is the total energy losses from grid transmission from generation station to our end user? 30% losses. We are seeing from generation to end user till the last use of the power generation. 30% is the losses. Our grid companies are tremendously working on that, how to reduce that losses. This is the transmission losses, cable losses, transformer losses. There are varieties of losses. Similar way, even our data centers and labs has some energy conservations. There is options available. There is a losses. You are able to see this pie chart. Any of the labs or data centers, you can see 50% of the power consumption from IT equipments. Then 40% is cooling or HVAC equipment. 8% consumption from electrical equipment, that is including transformers, UPS, cable losses, whatever may be, extra, etc. And 1% lighting and other losses, 1% other losses. When you talk about the 50% IT load, there is no much scope to reduce the power consumption from IT side, because equipment runs, then only the production will happen, revenue will come. Without power equipment's operation, there will not be any production, or these are revenue generations. We cannot switch it off the equipment. Equipment should run. Then what is the other options? There is a 8% power consumption from the equipment side. So with this equipment, 8%, there are some losses. The one thing is, I'm not talking about transformer. Today I'll concentrate only on critical area, which is comes under UPS as well. The one of the important topic is UPS. Opted for high efficiency UPS. Today's market, there are two kinds of UPS are available. One is conventional type UPS, that is average 12% losses. Any conventional UPS are having 12% losses. Another type UPS is the model UPS, which is 4% losses. You can say 96% efficiency. This 12% losses of UPS, if you replace straight away with 96%, that is 4% losses, you will save 8% power losses. Over a period of time, if you calculate for average year or average ROI calculation, within 2 years, we can able to get the revenue of get the cost of the equipment, UPS equipment. I strongly recommended any UPS, conventional type UPS, if it is above 17 to 20% losses, you can straight away recommend it to your management, or you can take the initiative and replacing with higher efficiency UPS. Even though today's UPS, we have easy mode, eco mode, we call it energy conservation mode. That means the loss will be almost nil, zero. So the power is straight away going through UPS, but UPS operation will be minimal. If using that kind of high efficiency UPS, we can straight away reduce the 8% losses, which is achievable, measurable and achievable. The second option is best cooling practices. See, there are 40% energy consumption from the cooling system. Okay, again, I'll not talk about chiller side, that is different part. I'll talk about only inside the of labs and data centers. What are the best cooling practices? First one, hot and cold oil containment enclosure configuration, which is one of the important practice in the best practices. If we have a proper segregated cold and hot oil containment, so you will save at least some 50%, 15% of energy energy efficiency from the cooling side. Again, realignment of the precision air conditioning units. That air conditioning unit should be there exactly on the hot air path, so that cold air go to the cold air section and hot air can come back immediately to the equipment, and faster cooling cycle can happen, so that it reduces the airflow losses as well. Realignment of equipments, proper containment, and blanking panels. That also one of the important point. There are multiple ways or open points available in the rack. You have to fill the racks where and all cold oil should not escape without proper heat dissipation. Blanking panel and wire manager gaps, that and all need to be closed, so that we'll have some at least 6 to 8% of the energy saving from the cooling systems. Even though if you have a DX mode air conditioning units, precision units, straight away you can recommend it for dual fluid units, both chilled water as well as DX mode. So that will have a backup efficiency, backup unit. General operations cooling chilled water mode will be operated. In case of something is not available chilled water, then DX mode will get into the picture, so that you will have a energy efficient PAC units as well as backup as well. With that air conditioning system, we can able to reduce at least 6 to 8% of the energy savings. Next point, operating the higher ambient temperature. We all know, yeah, the old kind of data centers, 18-degree, 20-degree set point is supposed to maintain. That concept and all ruled out now. As for SRE, American Society of Heat and Refrigerant for Air Conditioning Engineering, they recommended temperature should be 18 to 27 degree cold oil temperature. We can go up to 27 degree, 18 degree, forget it. Now we are in a 22. We can go up to 27-degree cold oil temperature. And even RH level also we can go up to 60 to 80%. If you reduce 1 degree of air temperature, I'll show one slide. You can see, if you set the temperature at 18 degree, you can take any scenario, even small 1 tier air conditioning unit as well as 100 kilowatt air conditioning unit also. If you set it for 18 degrees set temperature, average consumption per annum, the calculation, this is done by Energy Research Institution 3. They recommend their study conducted, if you set it 18 degree, so the power consumption per day is around 13 kilowatt kWh. If you set it to 24 degree, the power consumption is 10.5 kilowatt kWh. If you set it to 27 degree, power consumption only 9 units. So this studies clearly shows, if you increase 1 degree temperature, 3 to 4% power consumption will be reduced. So some of people using this concept and doing that energy temperature rise in the source end. Source end means chiller end. Generally, source end is not advisable. You have to do it in the end user end, like data center, lab center. If you raise it, automatically the impact on the chillers will be reduced and chiller get deloaded. So if you reduce in the labs and data center 1 degree, you will save 3% of energy consumption. Again, this is depend on discussion with your team, your discussion with the IT team as well, because sometimes it's directly impact the equipments also. We have to think over and working together with the data centers team, and we have to set it. What temperature is supposed to set from 22 to 24 directly you can set it. Anything 25 is good. About 25, 26, 27 need proper discussion and conclusion. Last point, minimize the idle IT equipments. Do you know, in 100 kilowatt data center, at least 20 to 20 kilowatt is the idle equipment power consumption. Idle equipment means only that internal components will be operational, but they'll not generate any production, or they'll not be useful to properly storage or productions. only it running on exhaust fans, cooling system, and minimum idle equipments. If you switch off all idle equipments, you can save at least 30 kilowatt. If it is a 500 kilowatt data center, minimum 40 kilowatt load power consumption can be reduced by switching off the idle equipments. Again, this need to be discussed with labs and data center teams. Identify if you have lesser consumption, probably 10% or 15% usage, we can do it virtualization, means transfer the load to other servers, and these equipments can be keep it off or keep it sleep mode, so that there will be huge energy savings from the IT load. With that, these are basic points, but as a facility management professional, you all working the day-to-day operations, if you work on the small steps, definitely you can save average 10 to 12% power consumption from the critical environment area. Thank you, and we'll go for question and answer session. Any questions?